Safety, practicality, and efficiency. These are the integral pieces to the foundation of civil and environmental engineering. In recent years, the village of Essex Junction has made an effort to realign its infrastructure to conform to these ideals. The village is currently looking at redesigning an intersection located near Essex High School on Educational and Drury Drive. Currently, this intersection experiences heavy traffic volumes during the morning and afternoon. Higher traffic volumes occur because this intersection is a main access point to the near high school. As there is congestion, ease of access issues, and unsafe conditions for pedestrians and vehicles. The goals for this project were to redesign the Central Street, Drury Drive, and Educational Drive intersection in Essex Junction. Design a multi-use path connecting the redesigned intersection to the nearby Route 15, Indian Brook Crossing, was also looked at, as well as the design of a multi-use bridge crossing parallel with Route 15 at Indian Brook. In order to produce an appropriate design proposal for the intersection and the bridge, an analysis of the site plan was performed. Data were collected by establishing a known elevation on the site using a benchmark on Lincoln Street. In addition to the survey data, numerous traffic counts were completed during the morning and afternoon peak hours. In order to visually see what was going on in the intersection, a vehicle simulation program to represent the current condition was used. The following is showing the flow of traffic during peak flow. This is from 7:30 to 8 a.m. on a normal weekday. Notice the line of cars that extend to Route 15. Multiple alternatives were considered to reduce the wait times for vehicles during the peak hours. The first option considered was a two-way stop design. The two-way stop was decided against because it was impractical and would likely cause an increase in accidents. The second option was a signalized intersection design. Now, a signalized intersection alternative was also rejected because traffic volumes at the intersection do not mandate signals. It was ultimately decided that the best alternative would be a roundabout that would replace the current four-way stop design. The following shows what a roundabout would look like at this intersection. Roundabouts have proven to be effective in optimizing traffic flow in both high and low traffic volumes. The reduction in queues is achieved by allowing drivers to yield to oncoming vehicles when appropriate, while allowing users to continue through the intersection without coming to a complete stop during times of low traffic volume. The design of the roundabout needed to satisfy the road standards for the village of Essex Junction, as well as accommodate the turn radius of a B40 school bus. A roundabout at the intersection of Drury Drive, Central Street, and Educational Drive will have a positive effects on the local residents of Essex Junction, as well as the students' safety as they commute to and from Essex High School. The fuel consumption was also reduced as traffic moves more efficiently through roundabouts, without the stop-and-go events found at traditional intersections. Roundabouts are initially more costly, but maintenance costs are lower compared to signalized intersection. In addition to the redesign of the Educational Drive intersection, this Capstone project will consider a pedestrian crossing over Indian Brook. A standalone bridge over Indian Brook would effectively transport bikes and pedestrians across the brook, while successfully avoiding the use of the Route 15 crosswalk for those traveling along the southbound side of Route 15. It is recommended that retrofitting the intersection of Drury Drive and Educational Drive with a roundabout improve safety and efficiency and allow traffic to continue flowing through the intersection at all times. It is also recommended to add a freestanding, prefabricated bridge across Indian Brook on the north side of Vermont Route 15. This will match the existing bridges in the village and reduce required construction time.